MRI, magnetic resonance imaging. A technique using electromagnetic field and radio frequencies instead of X-ray to visualize the human anatomy. Its magnetic strength is several thousand times more powerful than an industrial magnet. Please keep in mind that this magnetic strength is 10 times stronger than the Earth's gravitational pull. 3 Tesla MRI produces an extremely powerful magnetic field. To demonstrate its power, we'll try bringing a ferromagnetic metal object susceptible to magnetic fields near the MRI gantry. Next, a lightweight ferromagnetic object. Never bring ferromagnetic objects near the MRI system. This is the most important point to remember. We'll try another experiment, this time using a chain. As the chain nears the gantry, the magnetic force suddenly increases from 1 meter away. This graph shows the increase in magnetic force per distance from the MRI gantry. 1 meter from the gantry, the magnetic force rapidly increases in power. Within this zone, the magnetic pull increases exponentially as the object nears the gantry. This is a comparison of 3 Tesla and 1.5 Tesla magnetic field strength. Up to 1 meter from the gantry, the magnetic fields are nearly the same. Beyond that point, the 3 Tesla magnetic field is twice as powerful as the 1.5 Tesla. The magnetic pull is seemingly nil. Then suddenly it grows irresistibly powerful. This difference is the real danger of 3 Tesla MRI. How and when a ferromagnetic object will react to the magnetic pull cannot be foreseen. It differs with the shape of the object and its direction of approach. Remember, the magnetic field is always on, even when the MRI system is not being used. Accidents can also easily occur during cleaning or maintenance, so establish a system of risk management and educate all personnel having access to the room. Before entering the MRI room, the first thing you should do is to check for ferromagnetic objects on your person. In your breast pocket, are there scissors or tweezers? A pen or pencil? A pen contains metal and can easily become a projectile. A nameplate or film badge may also contain metal, causing it to fly off and injure someone. This stethoscope did not respond to an industrial magnet outside the room. Yet it responded to the powerful electromagnetic field. The bank or credit card in your wallet. While there is no danger of them going into the magnet, the information on the card can be erased. A mobile phone or electric data storage device could also be rendered useless, so do not bring them into the room. Paper clips and hairpins need special attention. Because they are small, they often become lost when they fly into the unit and cause malfunctions. What about a watch? We'll try placing a clock near the gantry. The magnetic field stops the clock's hands. Left in the magnetic field, the clock will become magnetized and unusable. Carefully check your accessories and the contents of your pockets before entering the MRI room. Next, check the patient thoroughly. Earrings and body-piercing jewelry used on all parts of the body. Necklaces, watches, rings, bracelets, and so on. Have the patient remove all accessories. Hairpins and hair clips are easily overlooked and need care. What about a hairpiece? The metal clip hidden inside the hairpiece. Hearing aids. Even the screws in your glasses, many things we take for granted, contain metal parts. Some objects that do not respond to an industrial magnet will respond to the powerful MRI magnetic field. So for safety's sake, instruct patients to remove all items from their person. What about pockets? A locker key in the pocket is easily forgotten. Don't forget hospital consultation cards and electronic money, which can be erased and rendered useless. Now, have we checked everything? Wait a minute. Does the patient have any ferromagnetic implants? Cardiac pacemakers will cease to function normally in the powerful magnetic field. Patients with pacemakers are forbidden from entering the MRI room. Surgically implanted clips and plates can move or become dislodged. Artificial limbs and joints also pose a danger, for they may be pulled by the magnetic force. Interview patients to confirm the absence of such devices before allowing them to enter the room. Besides the magnetic field, MRI poses another danger, that of heat generated by radio frequency waves. Metallic substances, even if non-magnetic, can become hot and burn the patient. Be sure to remove disposable hand warmers as well as magnetic therapy patches and nicotine patches, which have an aluminum backing. Eyeshadow and eyeliner and even colored contact lenses often contain metals that can cause burns, as do tattoos. Metal can also affect the quality of clinical images. In this image of the head, the area indicated by the arrow is distorted. The cause? A hairpin. The cause here, dentures. Here, the artifact is caused by the patient's metal belt buckle. A bra or other undergarments may contain metal parts that can also distort images and hinder diagnosis. Check the patient thoroughly one more time and, for safety's sake, remove all metallic objects. What can you do to ensure the patient's safety and prevent accidents before they happen? First, pre-screen the patient for the presence of any magnetic or metallic objects by interviewing or using a checklist. Always provide a dressing room and locker for belongings outside the MRI room. Keep a portable metal detector within the MRI work area. Double-check the patients for metallic objects there before they enter the MRI room. Post warning signs in readily visible areas, so patients will be aware of the need to check themselves. Prepare special pre-checked medical implements that can be used inside the MRI room. Label them so they are instantly recognizable. Bear in mind that new internationally standardized labeling is coming into effect to make safe and unsafe implements clearly distinguishable. Use only non-ferromagnetic intravenous drip needles. Next, the precautions you should take during the MRI exam. In the powerful 3 Tesla magnetic field, rapid motion of the head or body can cause dizziness or vertigo. You should therefore move very slowly when near the gantry. Burns may occur during the exam even if the patients have no metal on their person. The cause? Electrocardiogram cords. If looped, the cords can grow hot from the high-frequency current. When connecting the electrodes, make sure the cords do not become looped. An RF coil cable may sometimes form a closed loop with the patient's body. Please insert a pad so that the cable does not contact the body. Parts of the patient's body may also form a closed loop, such as thighs, knees, ankles, arms, and torso. Insert a non-conducting pad in places where skin might touch and form a closed loop. During mammography exams, an arm can easily form a loop with the torso, so be careful. How does one cope with an electrical power failure? During a power failure, the couch will no longer move automatically. Even if the electricity goes out, the powerful MRI magnetic field will remain active. Remember this fact when removing the patient. In the confusion of an emergency, make sure not to bring magnetic medical equipment into the MRI site. Many accidents involving projectiles occur at this time. Oxygen tanks, stretchers, and IV stands reportedly account for nearly 70% of projectile accidents. This is the proportion of people who have inadvertently brought ferromagnetic objects into the MRI room. Most accidents occur in the confusion of an emergency. Always bear this fact in mind. Caution! Do not enter. A metallic object has been detected. Recently, more and more facilities are establishing fluxgate sensors to prevent accidents before they happen. If a projectile accident should occur, do not attempt to forcibly remove the projectile. This is extremely dangerous. Call a serviceman immediately so that a secondary disaster does not occur. If by some chance a serious injury occurs, it may be necessary to shut down the magnetic field. The magnetic field can be shut down in a short time by pushing either the emergency shutdown switch in the examination room or the stop button in the alarm box in the control room. This will induce a unique phenomena of the semiconducting MRI magnet, a quench. When the magnet loses superconductivity, it develops increasing electrical resistance and grows hot. The heat causes the liquid helium used as a cooling agent to vaporize and erupt in the form of steam. The helium gas is normally vented outside through a special ventilation duct. The great volume of steam can be mistaken for a fire, so it is important to notify the fire department. If the helium gas should leak into the room, where it can potentially lower the oxygen level of the air, an oxygen monitor will detect this abnormality, and an alarm buzzer will sound, causing ventilation to begin automatically. If a quench should occur while you are performing a study, immediately evacuate the patient from the MRI room. A powerful magnetic field continually surrounds the MRI system. With new technological advances, higher magnetic field strengths are being used to provide higher resolution images. Therefore, even very small objects pose extreme danger. I was in a hurry, or I forgot. Casual attitudes like these may lead to irreparable accidents. To protect the lives of patients and coworkers, conduct hospital training sessions regularly and whenever there are personnel changes.
An earnest request from Canon Medical Systems.